Welcome viewers to the fourth lecture of the online series of lectures on Introduction to Category Theory. Last lecture we discussed the basic notion of an Olog, and we also discussed two important features of Olog called types and aspects. So we also discussed what it means by an aspect to uphold a functional relationship and gave examples for that. In today's lecture, we are going to start off from the non-functional relationship between two types and invalid aspects that we have written down here. So consider the following two examples. The following two arrows a person has a child is the first example. The second Olog being a mechanical pencil uses a piece of lead. Okay, so for this example, the aspect has is not a valid aspect. Is not a valid aspect. Since the instance functor, we discussed about the notion of instance functor in the last lecture. So the instance functor, in this case, acting on the aspect has, will not be a function from the set of persons to the set of children. Let me explain a little more about this. So this was the Olog. This was taken to be the Olog. I mean that there are two types and they are talking to each other by means of this aspect as, and this aspect is not a valid aspect since under the instance functor this aspect is not a function from the set of persons to the set of children. Okay? So why is it so? A person from the set of persons, what I mean is a member of this set. This is a set, and I'm picking up a member from this set, which is a person. A person from the set of persons can have more than one child from the set of children, from the set of children. So let me underline the sets here, the set of persons, the set of children, here again the set of persons, and the set of children. Okay? So one element from the set of persons can point to two elements of the set of children, which by definition is not a function. Okay? And also, a person may not have any children at all. May not have any child at all. Okay? So there can be elements here in this set which do not have an image in this set of children. Okay? So it's not a functional relationship between these two sets, and therefore this as here is not a valid aspect. Okay. What about the second example? The second example here, as you can see from the whiteboard, gives an aspect between two types, a mechanical pencil and a piece of lead. Alright? So let me explain a little more about the second example. In the second example, instant functor acting on the arrow, uses is the arrow. Uses is not a function again. Is not a function from where to where? From the set of mechanical, from the set of mechanical pencils, to the set of pieces of lead. Why so? Because the same mechanical pencil is allowed to use more than one piece of lead. Okay? So it does not satisfy the definition of the function. Alright? So, uses here is not a valid aspect between these two types. Alright. So now let us move to the reading of aspects and paths as English phrases. Okay? So let me elaborate on what it means by phrasing aspects and paths. Okay? So reading aspects and paths as English phrases. So, given an arrow, and we know that the arrows are aspects. So, F is an aspect between the types X and Y. This can be read by first reading the label on his source box. Label on his source box. Okay? Source box X. Okay? So what is the source box of this aspect F? The source box is X here, and whenever we have a box, we have a label on that. So we have to read that label on its source box first, and then the label on the arrow. The label on the arrow. So there will be a text here written above the arrow. We have to read that. And finally, the label on the target box Y. The label on the target box Y. Okay? So, let me give you an example. The arrow a book has as first author a person. So this is the path. So how do we read this path? It is to be read as a book which is the tape, which is the label on the source box. Okay, the one that we have written down here, that we have to first read aloud the text written in the source box, or the label of the source box, which is here a book has as first author. So we are reading the label of the arrow, which is as first author, and then we have to read the label of the target box, which is a person. Okay, so it is read as a book has as first author a person. Okay, good. So there. So note here that if we just modify this Olog by this, a book has as author a person, okay, by dropping the word first from this aspect, it will not reflect a functional behavior. Why? Because a book may have two persons as authors. So it does not reflect a functional behavior. So it's not a valid aspect. Alright? This is not a valid aspect. Okay. So why this is so? Let me elaborate on that. The action of the instance functor. So if the instance functor act on this aspect has as author, okay? What I mean is the instance functor acting on this aspect has as author this guy will not be a function from the set of all books. This will not be a function from the set of books. From the set of books to the set of persons to the set of. So the instance functor acting on the aspect as an author will not be a function from the set of books to the set of persons. Okay. Alright. And for that reason, this has as author will not be a valid aspect between the two types, alright, of the Olog. Okay, now we need to know the rules of good practice for aspects. So let me list the rules of good practice for the aspect. Let me erase the whole board. Rules of good practice. Rules of good practice. Rules of good practice for aspect. An aspect presented as a labeled arrow. We all know that aspect is a labeled arrow, presented as a labeled arrow. Pointing from a source box to a target box. The arrow text should be the arrow text should be the air text should one begin with a verb. Okay. Let's say for the last example we had a valid aspect given by has as first author, and there the label started with has, which is of course a verb. Okay. 2. The second rule is to yield an English sentence. When the source box text, when the source box text followed by the arrow text followed by the arrow text followed by the target box text followed by the target box text is read. And thirdly, this should refer to a functional relationship. Okay. To elaborate, each instance of the source type so here I write it by means of the action of the instant functor. Each element of the set I source, okay, where the source is the type and I source is the set representing the type, okay, and we are considering each element of this set, okay, which is precisely an instance of the source type, okay, and this should give rise to specific a specific instance of the target type. Inside bracket we write a unique element of the set I target. Okay? And only then this aspect, the underlying aspect will uphold a functional relationship. Okay? Alright? Okay. Now we come to another important feature of an Olog called facts. Okay? So far so good. We move to the discussion on facts. In order to have facts, we need two paths with certain conditions. All right. So let me discuss these things in detail now. First, how is a category different from a graph? We need to understand how is a category different from a graph. Different from a graph. Okay? A graph is a collection of vertices connected by edges. Sometimes there are edges from the vertex to itself, which are called loops, and that's it. So a graph is the mere collection of vertices and edges. Okay? There is no other information attached to a graph. But what about the category? Okay? It is the path equivalence. It is the path equivalences which exist in categories, but don't exist in graphs. Don't exist in graphs. Okay? That made category theory so powerful. That made category theory so powerful. Theory so powerful. Okay, now by means of an example, we'll try to understand what it means by path equivalences. Okay? Right? So let me give you an example. So given an Olog, the author may want to declare that two given paths are equivalent. What does it mean? Consider the following Olog, where it starts from the crimson and goes to another type. Okay, you need a bigger box. Goes to another type. Up here, W, M, where W is a woman and M is a man. Alright? And this aspect is given by as parents. As parents. And the other type is that of a woman. And there is an aspect coming to a woman which is called is as W, and this aspect is written as mother. Okay? So let's analyze this Olog. A person has as parents up here W, M, where W is a woman and M is a man. And here gives as W means this sort of projection from this pair to the first entry or the first element. Not an element, it's the first entry, let's call it an entry. W. Okay? So one can easily check that it reflects a functional relationship. Alright? Okay. So how how do you translate this fact in using English sentence? Let's try to do it, okay? Let's try to do it without invoking the instance function, okay? Just reading it out using our knowledge in English, okay? An English speaker, this refers to what I am writing now, refers to this Olog. An English speaker will agree with the fact that, that a woman parent is called a mother. Is called a mother. Okay? That's the definition of a mother in English. A woman parent is called a mother. Alright, so if this is A, this is B, and this is C, right? What about C here? C. Then the two paths from A to C, right? The two paths from A to C should be equivalent. Okay? So one path is this one and the other path is this one. They should be equivalent according to the English speaker. Mathematically, we say that the Olog here commutes. Okay? It's a triangle, the triangle of an Olog. It's a triangle of an Olog and it commutes. It stays mathematically. But in English language, if you translate this idea of commutative diagrams in English, it says that a woman parent is indeed a mother. Okay? So path equivalences here that we can see are simply commutative diagrams in terms of mathematical argument. All right. Okay, so we discussed commutative diagrams towards the end of the second lecture, and it indeed is equivalent to the path equivalences that we had discussed here. Okay. All right. So we'll carry on with the rest of the lecture in the second segment. Thank you very much.